Right, welcome back. Happy Monday morning. I believe I left you all on Friday with something to do. So I hope you have this graph already graphed over two periods from negative pi over 2 to a positive pi over 2. Okay? We are looking at the sine graph now. So we're going to try to find our inverse function, or really we need to find what restricted domain will allow us to have an inverse function. Okay? First question. Is sine a function? What test do we try? What test was it? The vertical line test. Okay? Is sine x a function? Yes, it is. Okay? Second question. Is sine x a 1-to-1 function? Question. What test are we going to use? The horizontal line test. Okay, so when we do the horizontal line test, did it pass the horizontal line test? Oh, right there. It crosses at two different points. It does not pass the horizontal line test. Therefore, it's not a one-to-one function. But I believe on Friday we talked about restricting the domain, the x values. Okay? We all know sine theta or sine x goes on forever. Okay? I just asked you to graph it in between negative pi over 2 and pi over 2. That was one interval. Can we restrict that interval even more to have a one-to-one function? Means I need to cut some stuff out. I need to cut out these hill things because that's where we're going past. That's where the horizontal line test is going through at 2 times when we're going over these hills. Okay? Somebody might say, well, what about from 0 to 2 pi? No, we still have hills. Okay? There are several places that you could cut this, okay? I'm just going to tell you that right now. So if you pick something different than what I picked, it's probably okay, as long as it passed the horizontal line test. But most mathematicians are going to go back and say, we want it to be 0, include 0, or be somewhere around 0. So the origin is kind of important. So we're going to start looking here at the origin and say, where in the world could we break this to make it have a one-to-one function, or to be a one-to-one function? Well, if I go back from 0, what about here? Starting at the bottom and going up to the tops before we go down the other hill. So if we broke this function and just took and made our restricted domain be between negative pi over 2 and pi over 2, would that include, number one, all of our range options? Does that include from negative 1 to a positive 1? Yes, it does. And does it pass the horizontal line test if I started doing this? Yeah. It's passing the horizontal line test, okay? So we have a piece. If you pick something different, that is okay. Somebody could have picked from here to here, from negative 3 pi over 2 to negative pi over 2. That would have worked also. See, it's on that downhill slope. Or even over here from pi over 2 to 3 pi over 2. From here to here, it's on that downhill slope. Those would have worked also. So if you picked those, great. From now on, we're going to use what the book does and what mathematicians like. That's where they have the 0. So our restricted domain from now on will be from negative pi over 2 to pi over 2. So that's the section we're going to look at going forward to find an inverse sine function. Okay? We will talk about domains and ranges, so let's go ahead and talk about the range of this. Remember the domain are your x's. What is the range? Your y's. I think we talked about that last week. So what is the range of this function when I've restricted the domain? How low do we go? And how high do we go? That's right. Will it include, remember this bracket means it will include -1 to a +1. It will include both of those numbers. Okay? So now if we restrict our domain, we have a 1-to-1 function. Okay? We're going to keep going because now I want to graph the restricted domain. I believe I've done something. Oh, maybe I can't do it. I don't know. Let's see. Here we go. File. Paste. I did. Okay. Sorry. I had copied that and I just wanted to paste it so I could have it and not have to draw them every time. It was about handy. Okay. So I'm actually going to make this much shorter, much smaller. But we're going to graph now you get to watch me play with my board. Should be okay. A little bit more in the center. So, now we're going to graph y equals sine x from -π/2 to π/2. I have restricted the domain even more than what I had asked you last week. So we're going to go back to -π/2, which is just -90 degrees, and to π/2, which is a +90 degrees. So that's going to be my x's. Remember, this is your x-axis. My y's, so my range is going to be what? Up to 1 and down to -1. And sine 0 is 0. Our first point's going to go up. Our next point's going to go down. So it's going to look like this. It's going to look like that. Okay? Now, I'm not going to be crazy in particular which way your line goes, but it should not be a straight line. If you remember your sine curve, it's not. It's curving down like this, meaning if I kept going, it would go to the x-axis. This side would go up. Okay, those little dotted lines are not there. They just kind of show what's going on. So this is kind of like a happy face smiling up. This is kind of like a sadder face going down. Like it's Monday morning and I don't want to be doing this right now. Okay? Can we graph or can we plot some points? Because if you remember, last week we plotted some points. And if you have points, can we find the inverse function of those? So this point right here, if I wanted to give it coordinates, it would be, the x would be -π/2, the y would be -1. This point right here, pretty easy. It's the origin, 0, 0. Over here, we have the x value is π/2 and 1. Now, if I wanted to graph the inverse sine, okay? So now it's kind of crazy to think, we've talked about inverse sine before, but now what are we going to do to find the equation and to graph it, okay? If you remember our 3 steps from before, oh my goodness, that was several days ago now. Step 1 was replace the f of x with y. It's already there, okay? Then we have to switch the x's and the y's, okay? And solve for y. So how do we solve for y? How do we solve an angle? Do you remember? We're going to use that other button, that sine -1. So the inverse sine of x will simply be written like that. So this is your equation of the inverse sine. It'd be helpful if I could spell. Okay. Now when we go to graph, I'm probably not going to use those that I did earlier. I'm going to draw new ones because it's just as simple. Okay? So now the rules of graphing from your original function to your inverse function, we're simply going to switch the x's and the y's. I know a lot of you were talking about negatives it's okay. We're simply just going to switch the x's and the y's. So this point right here that I've circled, negative pi over 2, negative 1, when we switch those x's and y's, a point over here would be negative 1, negative pi over 2. So I went back to negative 1, and I went down to negative pi over 2. Okay? Now, labeling is a must. They could look like they're the exact same points. It's up to you to label your x-axis, the negative 1. The y-axis is negative pi over 2. Okay? Now, go to the next point. If you've got 3 points, you can do this. 0, 0. When we switch that x and y, guess what? We're at the exact same point. 0, 0. Okay? And the last point, pi over 2, 1, would become 1 pi over 2. So that point is 1 pi over 2. Okay? Now it still looks like 3 points and I could draw a straight line. Okay? But we're not going to. So I'm going to kind of change color. See how this one is kind of frowny face down? When I reflect it across the y equals x, it's actually going to go smiley face up. Okay? It's going to be reflected across. Okay? This piece where it goes kind of smiley face but going down, I'm going to do frowny face going down. Another way to look at it will be they've switched axes. The original function, see this dotted line, is going to hug or curve around the x-axis. On the inverse, it will do the opposite. It will curve around the y-axis. Okay? So that kind of gives me an idea of which curve my line should be. Again, I'm not going to get too technical on which one it should be. Okay? Kind of looks like a straight line. It's okay. I might put some lines on it for you, but I'm not too crazy about that. So we have graphed sine and its inverse. Little hint, these will never change. So on a test, I'm not going to change and put any numbers in there. I'm simply going to ask, graph sine x from on the restricted interval so it has an inverse. Okay? This is what you will graph. This exact thing right here. Okay? If I ask you to graph sine, the inverse sine over its restricted domain, this is exactly what you're going to graph for sine x, sine negative 1. Okay? They will not ever change. If you have them, you have them. Okay? One thing we will talk about is the domain and range of each one. So I'm going to scroll just a little and list those because I will ask you to write the domain and the range of each. Okay? So let's start with the original function, sine x, the domain. And we're going to stick with interval notation just because it's easy. And I gave it to you at the top. I won't always give it to you. I might ask you, what is the restricted domain for sine to have an inverse function? And you're going to tell me it's going to have to go from negative pi over 2 to pi over 2. Okay? What is its range when you have this domain? Okay? What does it go down to? What does it go up to? You're right, it's going to go down from negative 1 to a positive 1. These will not change. Okay? Now, let's go on to the inverse. What is your domain of the inverse? Your x's. Where did we start and where did we end? Now, those aren't points, they're just lines. Okay, where did we start, where did we end? For your x's in the inverse sign. That's right, we started at negative 1 and we ended at 1. And the range, what did we go up to? What did we go down to? Where did we start? Where did we end? Your y values. That's right, negative pi over 2 to pi over 2. Okay? This going to change for the sine function. Is there something you notice about the domain and the range in these pieces? The domain of the original is the range of the inverse. The range of the original is the domain of the inverse. The x's, domain, and the range, the y's, were simply switched in an inverse function. Okay? So now we're going to do this all again for cosine. Oh, I know. It's a little bit crazy. I'm going to try to paste what I had done because I want a bigger piece now. Okay? So for y equals cosine x from negative 2 pi to 2 pi. That was your homework from Friday that we're going to look at today. I need you to graph. So, where does cosine start? Well, we're going to go back. I start at 0 and do my quarter periods. Pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to go in negative. 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay? Cosine starts up at 1, and it goes down to negative 1, goes up, and goes back up. I need to probably put my negative 1 down there. And it's going backwards the same, whoa, kind of a point. Okay? This is your y equals cosine x, okay? Same questions we're going to start with. Is cosine x a function? Remember which test? We've done that already today, vertical line test. And then is cosine x a 1-to-1 function? Which test are we going to use? It's about the horizontal. Well, is it? Is it a function? Yes. Is it a 1-to-1? No. It still has these humps that are plaguing us like they did with sine. Okay? So where can I restrict cosine so that it will be a 1-to-1 function? What is its restricted domain? Okay, still a lot of answers you could give me. Mathematicians like to stay around the origin, but are we going to do the same as we did for sine and go from negative pi over 2 to pi over 2? Is it a 1-to-1 function between negative pi over 2 and positive pi over 2? I'm not going to draw all my lines because I want to erase this. It's not. It's going to hit it 2 places. Okay, so I'm going to take that away. We will not have the same domain for cosine that we had for sine. Okay? So, could we go and do that? Of course we could. It's starting at the top, going down. But like mathematicians, remember they like to have 0. Okay? They also kind of like to have positive numbers. So in this one, mathematicians will say what we will go forward using is 0 to pi. We will start at 0 and go down until we get to pi. Okay? So we are going to look at these. I know you could have had a lot of answers. They're probably correct. But the one we're going to use from now on is 0 to pi. We're going to include our origin, our 0, and all of our inputs will be positive, so that's why they like that. What about the range? Where do we start? Where do we end? Okay, or where do we go down and up to? We always start with a smaller number. Our range will be negative 1 to 1. That will be the same with sine and cosine. Okay, it's just our domain that will be different. All right, so let's keep going. We're going to try to do this a little bit quicker so that we can get through both of these in one session. Okay? So, starting with y equals cosine x. Now, on our new restricted domain between 0 and pi. Oh, you know, I probably could move this. Move it a little down and a little this way. I don't know why that doesn't want to just go with me. Okay, there we go. I'm going to leave the other one for down. But I'm starting at 0. At 0, I'm up at 1. And then at pi over 2, 90 degrees, sine 90 is 0. And then at pi, I go down to -1. Okay, so this is the exact same piece from the other page. I've just restricted the domain and only have this section graphed. Okay, I'm going to go ahead and give you my points, 0, 1, so this is my 0, 0, 1, and then pi over 2, 0, and then this point down here is pi, -1, okay? This is our graph. Will always be our graph, okay? When we have the inverse, so instead of doing the whole process, what is the inverse of cosine? Y equals cosine -1 of x. And when we plot these 3 points, where are we going to be? So 0, 1, so here we go, start at this point, 0, 1. The inverse point would be, switching your x's and y's, you go over to 1, 0. And there's my point, 1, 0. Next, this point here, which is pi over 2, 0, we would simply go 0, pi over 2. So I'm going to go ahead and put that point there. Then last but certainly not least, the last point, which is pi -1. My x will become -1. My y will become pi. So that point is up here, which is -1 pi. We've just switched our x's and our y's. Now I have to kind of look back and say, okay, this graph from here to here is kind of doing this. And I'm going to have to do the opposite. And it's going to go, oh, I changed colors and I didn't need to. Okay, this piece here to here is going to be smelly face up. I'm going to do kind of smelly face down or frowny down, whatever you want to say. Or you can think, okay, this one is curving on the x-axis. Remember our original cosine graph? The inverse function will be curved along the y-axis. So it should look like the same graph if you turn your page sideways. Okay? Last piece. Let's talk about domain and range. The domain of our original cosine x, I've listed it at the top, but we can see x's start at 0 and go to pi. And the range, what are we going up and down to? Start at -1, we go to 1. We always start with a smaller number, that's why our negative will go first. For -1 to 1. Okay? These will always be the domain and range for this cosine function to be 1 to 1. Always will be this range and domain. Now, what about the inverse function? What is the domain of our inverse function? Meaning, x's, where do we start? Where do we end? Or we can look at the original range will be the inverse's domain. So it's from -1 to 1. And the inverse range will simply be the original's domain. So the range will be from 0 to pi. Always be the inverse cosine's domain and range. Some things you're just going to have to memorize in this lesson. Okay? All right. You guys are doing very well. I will tell you one more piece. Sometimes, I know it gets confusing, but multiple people discovered math at the same time, and some called it one thing, some called it the other. So I'm just going to let you know in case you see, sometimes you're going to see y equals arc sine of x. Okay? They're going to write it a little different. This means y equals the inverse. I spelled it wrong twice today. Inverse sine x. We have been writing it like sine -1. They are all the same thing. Okay? If you see this arc sine, that just means the inverse sine. That's how I'm going to read it. That's how we're going to see it. But different pieces, different places, you'll see it written differently. They all mean the same thing. And I could put cosine in this at the exact same place. Okay? That means, or tangent, or any of the others. It's going to mean the same thing. Yeah, somebody's phone is turned on in class. I can't believe that. I would love for you to try to figure out tangent. It's in your book. But could you do tangent on your own? We'll have a few problems. I'm not crazy stressed about this lesson. I hope you're not either. But we'll probably wait till tomorrow because I'm probably going kind of long to talk about tangent and some other problems to finally do with this lesson. So I'm going to say goodbye for Monday. Hope you've had a great day. Bye.